This is the start of our material on section 7.4. 7.4 is called the other trigonometric functions. In by other, the textbook means tangent, cotangent, secant, and cosecant, I think. And I feel like I've prepared us for this section already. We've actually done a lot of the material in this section. So the video treatment of 7.4 per se is going to be pretty short. There is there are a few really, really important ideas we got to get across here. But as far as working with tangent, cotangent, secant, cosecant, we've been working with them for a while, so there's not really much that's surprising. Okay, so what's important in this section? So I'm going to write these bullets here. Sine theta and cosine theta can be used to describe the other trigonometric functions. And we've already talked about this. And this is a really, really important idea. And of course, you got to have these things memorized. Tan theta can always be thought of as sine theta over cosine theta. Cotangent theta, which is the reciprocal of tangent, can be thought of as cosine over sine, and you got to keep those straight. And secant theta is 1 over cosine, and cosecant theta is 1 over sine. This is very fundamental, and it's really the main way of keeping track of these other functions is to remember how they're related to sine and cosine. Now, there's a handout that I'm going to post in Canvas where I talk a little bit about why we use the word tangent and secant, because there's a tangent line. You can talk about a tangent line to a circle or a secant line to a circle. And so the handout explains why these words are used. This is not required material for our course. It's only if you're curious about that. And it doesn't really help your understanding that much with the situation trigonometry is in the modern world. But so there is a handout that I'm going to post that talks a little bit about why the words, certain words are used. Okay. Now, also, for any angle theta, sine squared theta plus cosine squared theta equals 1. That's the most famous trig identity. Probably the most famous formula in trigonometry, I would say. So of course, you got to memorize that. You're going to use that for the rest of your life, I would think. And we can get 2 more identities from this. There are 2 related identities. And some teachers say memorize these. I don't say to do that. I think just kind of remember what this relationship is. What we're going to do is we're going to start with sine squared theta plus cosine squared theta equals 1. And I'm going to divide both sides by the same thing. First, I'm going to divide both sides by sine squared theta. And it's not too hard to see how this can be rewritten. I'm going to take this sum apart as 2 separate fractions. And now notice sine squared theta over sine squared theta is 1. Cosine squared theta over sine squared theta can be rewritten as cosine theta over sine theta squared. In 1 over sine squared theta, we can rewrite that as 1 over sine theta squared. And so now I have 1 plus cosine over sine is cotangent. That's cotangent squared theta equals 1 over sine is cosecant. That's cosecant squared theta. So this is the other one of those special formulas. It's called a Pythagorean identity because it's related to sine squared plus cosine squared equals 1. But I have never memorized it. I just know how to derive them when I need it. Sometimes this pops up in calculus, but again, in calculus I just derive it when I need it. Now, we can take that same sine squared theta plus cosine squared theta equals 1, and I could have divided both sides by cosine squared theta. In fact, you were probably already thinking that. And we go through the same steps, sine squared theta over cosine squared theta. I'm going to take this left-hand side apart as a sum of fractions. Whoop. Oh, sorry. I didn't realize I went off the bottom. And do the same thing. Now, sine squared over cosine squared can be thought of as sine theta over cosine theta squared plus cosine squared over cosine squared is 1. And 1 over cosine squared is 1 over cosine in parentheses squared. So now I can express this using other trig functions. Sine over cosine is tangent, so I have tangent squared theta plus 1 equals 1 over cosine is secant, so I have secant squared theta. Again, these are so similar. I used to have trouble memorizing them when I was a student, and I just remembered how to derive them because I never get it wrong when I derive them. So no need to memorize these, but know how to derive them. And it's sort of like you do the obvious thing and then you just sort of simplify. Like I don't think that's that mysterious. Okay, so a couple things. So I would not put these two on a yellow card. I know we've had yellow cards along the way. I'm trying to think, did I put yeah, we already had a yellow card with these guys, so that's good. That's not new. I think I did not make a yellow card with the Pythagorean identity originally, but somehow it should. It's so important. It's really got to stand out. And so we're going to quit this video here. Now the next topic is going to be a new yellow card. It's another really important property, but we'll deal with that in a separate segment.